Hello students, greetings to you all. Hope you all are safe and doing good by the grace of God. So we were dealing with Unit 4, Electric Charge and Electric Current. So this is the continuation of it, part 3 video. With this video, we'll be completing this Unit 4. So we'll quickly move on to the motivational quote for the week. If you are not willing to learn, no one can help you. If you are determined to learn, no one can stop you. I repeat it. If you are not willing to learn, no one can help you. If you are determined to learn, no one can stop you. Yes, my dear students, so start your determination towards your studies. With this quote, we move on to today's class. The topics to be concentrated in this session are effects of electric current, types of current, dangers of electricity, and precautions to be taken. So first we see the effects of electric current. So when current flows in a circuit, it exhibits various effects, and these three are the main effects we are going to see in today's class. First one is the heating effect, second one is the chemical effect, and third one is the magnetic effect. We'll see these three effects in detail in this video. So first we'll move on to the first effect, which is nothing but the heating effect. So this effect was studied by scientist Joule. So when the flow of current is resisted, heat is produced. This is because the electrons, while moving in the wire or resistor, suffer resistance, and work has to be done to overcome the resistance, which is converted into heat energy. So the conversion of electrical energy into heating energy is called Joule heating. So this is an important definition of Joule heating. So it is nothing but the conversion of electrical energy into heating energy is called Joule heating. So we have many appliances in our day-to-day life, right, which converts the electrical energy into heating energy. Here are some examples I have stated out. They are heater, iron box, toaster, and many more are there. You can also think of whatever appliances which converts electrical energy into an heating energy. Okay, these terms comes under Joule heating. Hope you are clear with it. So next we are going to see chemical effect. For this effect, we will see a short video, a short activity. Okay, so listen carefully, children.
Faraday made this observation. Take a big glass container and fill it with salt solution. Place 2 electrodes and connect it to the source of current. The electrode connected to the positive charge is called the anode, and the one connected to the negative charge is called the cathode. Sodium reduces to form sodium plus ions, and chlorine oxidizes to form chlorine minus ions. The sodium plus ions move towards the cathode, and the chlorine minus move towards the anode, forming chlorine gas. Electroplating. Electroplating is a method of moving ions through a solution to coat a metal. The metal to be coated is cathode, and the depositing metal is the anode. Take a glass container and fill it with copper sulfate solution. Connect the metal to be coated to the negative end of the power source, and the metal from which the coating is to be done to the positive side of the source. Switch the power source on. Copper is reduced to form copper plus ions, which travel through the solution to deposit on the cathode. The ions deposit on the surface of the metal that is to be coated. In this way, a layer of copper is formed on the metal.
Yes. So hope you understood what is electroplating, what is electrolysis, and so on. Okay. So with this activity, what we inferred from this activity So the positive terminal is said to be an anode. The negative terminal is said to be the cathode. So whereas in this activity, the copper wire, which is an anode, and the carbon rod is a cathode. So hope you're clear with it. So far we have come across the cases in which the electrons only can conduct electricity, right? But here, when current passes through electrolyte like copper sulfate solution, both the electron and the positive copper ion conduct electricity. So the process of conduction of electric current through solution is called electrolysis, and the solution through which the electricity passes is called electrolyte. So these two definitions are very important. So what is electrolysis? The process of conduction of electric current through solution is called electrolysis, whereas what is electrolyte? The solution through which the electricity passes is called electrolyte. So the next effect we are going to see is the magnetic effect of electricity. So what is magnet? We all learned, right? So here they use a right hand thumb rule. Okay, right hand thumb rule, it states that the direction of current is shown by the right hand thumb and the direction of magnetic field is shown by the other fingers of the same right hand. So what this magnetic effect of current shows us is a wire or a conductor carrying current develops a magnetic field perpendicular to the direction of the flow of current. So this is called magnetic effect of current. And the discovery of the scientist Oyster and the right hand thumb rule gives this idea. Okay, so this is called to be a magnetic effect of current. So the definition of magnetic effect of current is a wire carrying current develops a magnetic field perpendicular to the direction of the flow of current. This is called magnetic effect of current. So here in this diagram I have given you the right hand thumb rule where the right hand shows the direction of current and other fingers shows the direction of magnetic field. Next we will be going into a new subtopic which is types of current. So there are two distinct types of electric currents that we encounter in our everyday life. One is the direct current and another one is alternating current. So this shows the graph of direct current and alternating current. This shows the x-axis and y-axis where y-axis is current and x-axis is time taken. So for the direct current it is a constant current, whereas for alternating current, as the name suggests alternating, so the current varies. Okay, we'll see one by one. So first we are going to see direct current. We know current in electrical circuit is due to the motion of positive charge from higher potential to lower potential or electron from lower to higher electric potential. Electrons move from negative to positive terminal of the battery. Battery is used to maintain a potential difference between two ends of the wire. And the battery is one of the source for DC current, which is direct current. And the direct current is due to the unidirectional flow of electric charges, and some other sources of direct current are solar cells, thermocouples, and so on. And here the graph depicts the direct current as I have already told in the first slide. So for the direct current, it has a constant current. Okay, so many electronic circuits use direct current. Some example of devices which work on direct current are cell phones, radio, electric keyboard and electric vehicles and so on. Now we move on to the alternating current. As the name suggests, the current gets alternated. So it is not as same as the direct current. The current varies in this type of current. So if the direction of the current in a resistor or in any other element changes its direction alternately, the current is called an alternating current. The alternating current varies sinusoidally with time. So this wave in this graph, it is a wavy graph, right? So this wave is a sinusoidal wave. Therefore, alternating current varies sinusoidally with time. And this variation is termed to be frequency, where frequency is the number of complete cycle of variation gone through by the alternating current in 1 second. And in alternating current, electrons do not flow in one direction and potential vary between high and low alternatively. Thus, the electrons move to and fro in the wire carrying alternating current. And the domestic supply is in the form of alternating current. When we want to use an electrical device in direct current, then we have to use a device to convert alternating current to direct current. So there are two devices which is used to convert vice versa. Okay. So first one we see the rectifier. Rectifier is a device which is used to convert alternating current to direct current. Whereas the inverter is a device which is used to convert direct current into an alternating current. So rectifier is used to convert alternating current to direct current, whereas the inverter is used to convert direct current into an alternating current. So now let us see few symbols used in alternating current and direct current circuit diagrams. So we have already seen a cell and the battery, right? So this is a symbol used in the circuit diagrams. It represents, the first image represents the single cell. Okay, and the second image represents multiple cell, or it can be termed as battery. And the third image is nothing but the DC voltage source. And the fourth image, which is nothing but the AC voltage source. It shows the sinusoidal wave, right? So if this is represented in a circuit diagram, then the circuit contains AC voltage circuit. Okay? I hope you are clear with it. So yes, we'll see advantages of alternating current when compared with direct current. So there are various advantages of alternating current when we compare with direct current. We will see one by one. So the voltage of alternating current can be varied easily using a device called transformer. And the alternating current can be carried over long distance using step-up transformers and so on. Okay. And the loss of energy while distributing current in the form of alternating current is negligible. Therefore, the direct current cannot be transmitted as such. And the alternating current can be easily converted into the direct current. And generating alternating current is easier than direct current. And the alternating current can produce electromagnetic induction, which is useful in several ways. So now we have concentrated more on advantages of alternating current. Then what would be the advantages of direct current? Yes, so it is used in electroplating, electrorefining, electrotyping, and electricity can be stored only in the form of direct current. So next we are going into an important topic, which is dangers of electricity and precautions to be taken. So this topic is very useful and very informative as well. So listen to this topic carefully, children. The following are the possible dangers as far as electric current is concerned. Let's see it one by one. So there are possible dangers we come across in our day-to-day life. First would be damaged insulation. So insulation is nothing but which does not have current. So every wire is insulated with the material, right? So if it is damaged, then it leads to danger. So do not touch the wear wire, use safety gloves, and stand on insulating stool or rubber slippers while handling electricity. And next danger would be overload of power sockets. So in one socket, many connection would have been given. So this may lead into some dangerous hazards. So overload of power socket is another danger which we come across in our day-to-day life. So do not connect too many electrical devices to a single electrical socket. And next danger would be inappropriate use of electrical appliances. So always use the electrical appliances according to the power rating of the device, like AC point, TV point, microwave oven point, and etc. Next danger would be environment with moisture and dampness. So keep the place where there is electricity out of moisture and wetness, as it will lead to leakage of electric current. And next would be beyond the reach of children. So the electrical sockets are to be kept away from the reach of little children who do not know the dangers of electricity. So these are the safety measures need to be taken when you use electric current. Okay. So with this, we have completed Unit 4, Electric Current and Electric Charges. So let us have a quick recap of what we learned in today's class. So points to remember, yes, and we saw effects of electric current, types of electric current, and the dangers of electric current. So under effect, we saw the chemical effect, right? 3 effects: heating effect, chemical effect, and magnetic effect. So the process of conduction of electric current through solutions is called electrolysis. And the solution through which the electricity passes is called electrolyte. And we saw 2 devices, one is rectifier and another one is inverter. So the device used to convert AC to DC, which is alternating current, to the direct current, is called as rectifier, and the device used to convert direct current to alternating current is called as inverter. And we saw many possible dangers which is surrounded in our day-to-day life as well. Okay, so for your homework part, so list out few more possible dangers of electricity and the safety features while handling electricity. So take your classwork, write down, list it out, take a picture of it and upload it in Google Classroom. So this question carries 10 marks. Hope you all will complete your homework and submit it in Google Classroom. Thank you so much, students. Stay home, stay safe, and may God bless you. Thank you.